Okay, if this is 14, then A is 14, because if this is a parallelogram, then opposite sides are congruent. Okay, if this is 8, then this also has to be 8 because the diagonals bisect each other. Okay, to find x, if this is 78, this is 78 because of their alternate interior angles. All right, if this is 110, this has to be 70 because this is a straight line and those angles are supplemental. Okay, diagonals are congruent in a rectangle and in a square. Consecutive angles, meaning an angle here and here, like in a quadrilateral. Those are consecutive angles, and they're supplementary in every one of these. Because diagonals bisect each other, this has got to be equal to this. So 2x plus 10 must be equal to 5x minus 32. If I bring this over here, I get 3x. I add this, I get 42. So x must be 14. Okay, these are consecutive angles, so those are supplemental. So 9x plus 12 plus 114 must be 180. So 9x is going to be 180 minus those two things, which is 54. So x is 6. Okay, this is a rhombus, so these diagonals bisect the angles. So if this entire angle shown is 110, then this angle shown is 55. And this angle must also be 110 because the same thing. So this angle must be 55 because the diagonals bisect and the opposite angles are congruent. So 5x must be equal to 55. So x will be 11. Okay, here we have a triangle and all three angles must add up to 180. So 55 plus 90 plus x must be equal to 180. So x must be equal to the 180 minus this and this, which is 35. All right, this is a 30, 60, 90 triangle. And remember, the sides in a 36 go 1, root 3, and 2. And the root 3 is the longer side. So in other words, this right here is that side. So this shorter side is going to be this divided by root 3. So this is going to be 6 over, I'll call that x. That's going to be 6 over root 3, which is 6 root 3 over 3, or 2 root 3. And then, so this is 2 root 3. And then the long side is twice the shortest side. So if this will be this side here. So this is going to be 4 root 3. This is a 45, 45, 90 triangle. And remember, the sides are in the ratio of 1 to 1 to root 2. So this side is going to be 12 divided by root 2, which is going to be 6 root 2. And this side is the same. All right, this is a 30, 60, 90 triangle, so this ratios are inside of this. This is the 2 side. The short side is half of that, so the short side is 9. And the long side is root 3 times the short side, so this is 9 root 3. You may have memorized this Pythagorean triplet, but if you haven't, just do it the mathematical way. So we have x squared plus 24 squared is equal to 25 squared. So x squared plus 576 is equal to 625. That means that x squared is equal to 49, so x is equal to 7. Here we have 4 squared plus x squared is equal to 8 squared. That means that x squared is equal to 64 minus that, which is 48. So x is equal to the square root of 48, and 48 is 16 times 3. So this is 4 root 3. This is a 45, 45, 90 triangle. So this is root 2 times either of the sides. So this is 9 root 2. And you could do this the long way also. You could have just said that 9 squared plus 9 squared is equal to x squared. So x is the square root of 162, and 162 is 81 times 2. Take this out and you get your 9, and you end up with your 9 root 2. This is one of the most common Pythagorean triplets. So if this side is 5, this side is 5. And so we have, well, if you realize that this is a Pythagorean triplet, this is a 5, 12, 13 triangle. And so this must be the long side, so that must be your 13. But if you didn't know that, then just do it the long way. So you have 5 squared plus 12 squared is equal to x squared. So that means x is the square root of 169, which is 13. Here we have 7 squared plus 14 squared is equal to x squared. This adds up to 245. So x is the square root of 245, and 245 is 49 times 5. So you take this out and you get 7, and you're left with that root 5. Because you know this is a square, then the diagonal is root 2 times this. So x root 2 must be equal to 4. So x is equal to 4 over root 2, which is 2 root 2. Okay, because this is a right triangle and this is 5 and this is root 3 times that, you might recognize that this is a 30, 60, 90 triangle. And if you know that, then the sides are in the ratio of 1, the middle leg is root 3, and the hypotenuse is going to be 2. And what you have here is just 5 times that. This is 5, 5 root 3, and 10. And I showed a lot of work here, but you could probably have just done this right in your head. It's pretty easy to see. So you know that x is going to be 10. Now, if you didn't know that, it's no big deal. You just do the math. 5 root 3 squared plus 5 squared equals x squared. So this is 25 times 3 plus 25 equals x squared. 75 plus 25 equals x squared. 100 equals x squared. So x must be equal to 10. This right here is a 30, 60, 90 triangle, which means the sides are in the ratios of 1 times root 3 to 2. And so if you multiply everything by 8, you'll get 8 and 8 root 3 and 16. Okay, and so this is your 8 root 3. And so this right here must be your 16. Okay? And so now that we know that's 16, we can see that this is a 45, 45, 90 triangle. And that means that x must be 16 over root 2, which is 8 root 2. Give yourself, if you didn't understand that, give yourself some time to digest that problem. Okay, the altitude of an equilateral triangle is 15. Find the perimeter. So let's first draw this. We have a triangle that looks like this, and each of these are 60 degrees if it's an equilateral. And if we cut this down, this will become 30, so we have a 30, 60, 90 triangle. And if this is 15, this here is 15 divided by root 3. So I'll call this x here, and x is going to be equal to 15 divided by root 3, which is 5 root 3. The shortcut is you just divide 15 by 3 and then add the root 3. Okay, anyway, so this is 5 root 3, and this is twice the short side. So this is 10 root 3. And if all sides are the same, the perimeter is 3 times this. So 3 times 10 root 3 is 30 root 3. Okay, a square has 4 equal sides. And if the perimeter is 20, then each side is 1/4 of 20. And the diagonal, this is equilateral, so this is 45, 45, 90. So this is 5 times root 2. When you're finding the sides, the smallest it could be is the difference of these. So 23 minus 12 would be the smallest, so that's going to be less than the one of the sides. And the biggest it could be is 23 plus 12. So when you simplify this, you get it's between 11 and 35. Oops. Okay, the first thing you want to do is identify the long side. That's obvious. And then make sure the two sides add up to more than this. 16 is more than this. So this is a triangle. And then to find out what type of triangle, we'll go 11 squared. 8 squared plus 8 squared is 121. 64 plus 64, that's 128. I know that's 128. So this is less than. Because it's less than, this is an acute triangle. Because it's less than. Okay, first thing we're going to do is identify the long side and then check if it's a triangle. 16 plus 20 has got to be bigger than this, and that is, because that's 33. So this is a triangle. So then we'll take the long side and square it and figure out what that is with the sum of the other two sides. So this is 400. This is 256, and this is 289. Well, this adds up to more than 400, so 400 is less than. Because it's less than, this is an acute triangle. Because it's less than. Okay, first thing we're going to do is identify the longest side. Now, I know this is the longest side without using a calculator because 3 times 2 is 6, and this is less than 2. Because the square root of 4 is 2, so the square root of 3 is less than 2. So that makes this product less than 6. Anyway, or you could just use a calculator and figure out the longest side. So I do know it's a triangle. So I'm going to say 6 squared, I'll leave a space, and I'll put 3 root 3 squared plus 3 squared. This is 36. This is going to be 3 squared is 9, root 3 squared is 3. 3 times 9 is 27. 36 is equal to 27 plus 9. So this is a right triangle. And that's because it was equal. Okay, the longest side is 15. But 6 plus 8 is less than 15. That means we don't even have a triangle. This is not possible. So this is not a triangle. Okay, the entire triangle is here. So I need to know this entire side. I have part of it, so I need to find this, and then I need to find this as well. Well, this is the easiest one to find because this is an equilateral triangle. So because of those markings. So in an equilateral triangle, these two things are both 5, and this is 5 root 2. That was the easy part. Now, in this triangle, I can tell that this is a 5, 12, 13. Because it's a right triangle and we have 5 and 13, this has to be 12. Because this is a 5, 12, 13. That's one of the most common triplicates. But if you don't know that and you forgot that, just call this side x. And then we have x squared plus 5 squared is equal to 13 squared. So x squared plus 25 is equal to 169. So x squared is equal to 144 when we subtract. So x is equal to the square root of that, which is 12. So we found that this is 12. That tells us that this entire side from here to here is 5 plus 12, or 17. Now, this is obviously the longest side. So to figure out if it's a right triangle or what type of triangle it is, we're going to say 17 squared, and we'll say 5 root 2 squared plus 13 squared. 17 squared is 289. This 5 squared is 25, root 2 squared is 2, so this is going to turn into a 50, and 13 squared is 169. So this is 50 plus 169, which is, I don't know, what is that, 219? But because 289 is greater than that, this is an obtuse triangle. If we want to draw the median AD, we've got to start from A and go to the other side, and we've got to first find the midpoint. So I'll draw the midpoint, and I'll make sure we know it's the midpoint by doing that. And then I'll draw a line from there to there. Use a straight edge, and we'll call this point D. So that's the point AD, or the median AD. Okay, IK, here's I, and we got to go to the other side and hit this at a right angle, but we can't go inside the triangle because we can't do it at a right angle. This is going to go outside of the triangle. So I need to draw, extend this line here. So I used the ruler and I extended that line. Now I'm going to draw something from here to here, and I'm going to come at a right angle. So I'm going to get a ruler again, and I'm going to go from here to here, and I'm going to call this point K, and I got to do this to show that it's at a right angle. So that's the altitude IK. Okay, first thing I want to do is draw the triangle. So -5, -4 is the point there, -1, 2 is there, and 5, -2 is here, and this was W-O-N, and I need to use a ruler. This program doesn't let me draw straight lines, so I need a ruler on my screen. And I'll draw this. Okay, so we need to show that it's isosceles and right. Let's work on the isosceles part. For the isosceles part, we need to know the distance. So the distances of WO is going to be the square root of the x's, -1 minus a -5, plus the y's, which is 2 minus a -4, which is the square root of, this is -1 plus 5, or 4 squared, plus this is 2 plus 4, which is 6 squared, which is the square root of 16 plus 36, which is the square root of 52. Now, the distance of ON is the square root of the x, the difference of the x's, 5 minus -1, and the difference of the y's, which is -2 minus 2. So this is the square root of 5 plus 1, or 6 squared, plus -4 squared, which again is the square root of 36 plus 16, which is the square root of 52. So these are the same. So WO is congruent with ON, therefore triangle WON is isosceles. Okay, And we need to do this and this to show that they're isosceles. Now, to show that this is a right angle, we need the slope of this and the slope of this to see if they're perpendicular. So, slopes. The slope of WO is y2, which is 2, minus y1, which is a negative 4, over x2, negative 1, minus x1, which is a negative 5. So this becomes a 6 over negative 1 plus 5 is 4, which is a 3 over 2. The slope of ON is y2, negative 2, minus y1, which is 2, over 5 minus negative 1. So this is a negative 4 over 5 plus 1, which is 6, which is a negative 2/3. So these are opposite reciprocals. Because of that, we say that WO is perpendicular to ON. Therefore, triangle WON is a right triangle. And we show that with this here. First thing I'm going to do is I'm going to graph these points. So 4, 9 is the point, is the point here. 2, negative 7 is the point here. And negative 8, 1 is the point here. So I'll call this TON. And then I'll use a ruler to graph this. Okay, to graph the median NA, I start from here, then I have to go to the opposite side. So I need to know the midpoint of TO. So midpoint, let's do this in blue. Midpoint of TO. So the X value of the midpoint is, here's my T and O. So I have 4 plus 2 over 2, which is 6 over 2, or 3. The Y value of the midpoint is 9 plus negative 7 over 2, which is 1. So the midpoint is 3, 1. So I go to the point 3, 1, and I draw a dot. And then using a ruler, I go from N to that point. And I have to show that it's a midpoint by doing this. Do not draw a right angle over here, because we don't know if it's a right angle, even if it looks like one, but it's actually not. Okay, to do the altitude TB, well, coming from T, we have to hit this line at a right angle. So we need to know the slope of this line. So slope of ON. So the slope is the difference of the y's, 1 minus negative 7, over the difference of the x's, negative 8 minus 2. This becomes a positive 8 over a negative 10, which is a negative 4/5. So the slope of the perpendicular is a positive 5/4. So coming from, where are we? From TB. Coming from T, we have to rise 5 and run 4. But that takes us off the graph. So instead, I'm going to do the opposite and go down 5. 1, 2, 3, 4, 5. And go left 4. 1, 2, 3, 4. And that's the point right there. Then I'm going to take a ruler from T. I'll draw a straight line through that point into the other side. And because I know that this line is perpendicular to this line, because it has equal but opposite slopes, I know it's hitting this at a right angle. So I'm going to draw a dot there and call this A and put that there to show that it's at a right angle. Okay, the perpendicular bisector of ON. So here I need to know the midpoint and the slope of ON. Let's start with the midpoint. So the x value of the midpoint is the x's added up, 2 plus negative 8 over 2. And the y value of the midpoint is the y's added up, negative 7 plus 1 over 2. Oops, what am I doing? So the midpoint is negative 3, negative 3. So I go to negative 3, and I'm going to draw my little dot. Oops. And then I'm going to make a little marking here and a marking here. Notice I didn't use a single line because I would say they're equidistant here and here, and they're not. They're just equidistant between this and this. Okay, now, then I have to I have to go through this line at a perpendicular. So I need to know the slope of this line so I know the slope of the perpendicular. So the slope of ON. So the slope is the difference of the y's, 1 minus negative 7, over the difference of the x's, negative 8 minus 2. This is 1 plus 7, or 8, over negative 8 minus 2 is negative 10. So I get negative 4/5. I guess I already knew this. This was done earlier. I guess I could have copied that. So the perpendicular is positive 5/4. So starting from this point right here, I'm going to rise 5. 1, 2, 3, 4, 5. And I'm going to run 4. 1, 2, 3, 4. And I'll draw my dot. And then I'm going to use a ruler. And I'm going to go through those two dots. And I got to put arrows on either side. And I got to show that it's a right angle by doing that. So you need these markings to show it's a bisector, and you need this marking to show it's a perpendicular bisector. And that's it.